Hello everyone, I am Prakhya Jain, Assistant Professor, Department of Mechanical Engineering, HIT Mangalore. Today I am going to discuss about Module 4 of Fluid Mechanics, that is Dimensional Analysis. So I already discussed about problem 1 in previous video. So let's go for second problem using Buckingham Pi theorem. So the frictional torque T of a disc of diameter d rotating at a speed n in a fluid of viscosity mu and density rho in a turbulent flow is given by T equal to d to the power 5 n square rho function of mu divided by d square n rho. Prove this by method of dimensions. So here you can use either Buckingham theorem or you can go with Rayleigh method, but Buckingham theorem is very easy because number of variables here more than 3, so you can go with Buckingham Pi theorem. So first you have to look into the problem and you have to classify into dependent and independent variables. So as the expression is given here directly, that is T equal to d to the power 5 n square rho 5 of mu divided by d square n rho. So it is clearly seen T is a dependent parameter. So T is dependent, then remaining variables, that is d and mu rho, those are independent parameters or variables. So I can write expression for dependent variable as a function of independent variable like this: T equal to f of d comma n comma mu comma rho, where d is diameter, n is rpm, mu is dynamic viscosity and rho is density of fluid. So or we can rewrite that expression as f1 of t1 t comma d comma n comma mu comma rho, that is equal to 0. Take it as expression 1. So now we can count the number of variable. So that includes both independent and dependent variable. So here t, d, n, mu, rho. So number of variable equal to 5, n equal to 5. So then we have to write dimensions of each variable. So let me start with dimension of T. So as a unit of torque is Newton meter, so you know how to get dimension for Newton. There is a unit of force. So F equal to ma, kg meter s to the power minus 2 into meter, that becomes torque. So kg meter square s to the power minus 2, there is a unit for torque. So dimension becomes T equal to ml square t to the power minus 2. Then dimension for diameter, that is L, as diameter is measured in meter. Then N, that is RPM, revolution per minute. So revolution has no unit. A minute is a unit of time. So minute goes to numerator, then becomes minute inverse. So t to the power minus 1 is the dimension for N. Then dynamic viscosity. As we all know, unit of dynamic viscosity is Newton second per meter square. Dimension for Newton, that can be obtained by using a formula F equal to ma. So overall dimension becomes m L to the power minus 1 t to the power minus 1. Then rho, that is density, m L to the power minus 3, as density is given by mass by volume. So mass, that is kg by meter cube, kg per meter cube. So there's a unit, so dimension becomes m L to the power minus 3. So we can see here all m, l and t terms. So number of fundamental dimensions m, that becomes 3. Therefore number of pi terms from Buckingham Pi theorem, that is n minus m, number of variables minus number of fundamental dimension. So here number of variables is 5, number of fundamental dimensions is 3. 5 minus 3, that becomes 2. So we have to write expression for 2 pi terms. So before that we can rewrite the expression 1, that is f1 of t comma d comma n comma mu comma rho as like this. So equation 1 is written as f1 of pi 1 comma pi 2, that is equal to 0, because we are grouping the variables into dimensionless terms pi 1 and pi 2. So take it as expression 2. Then each pi term contains m plus 1 variables, where m is equal to 3 and is also repeating variable. So each pi term, that is pi 1 and pi 2, that contains m plus 1 variable, where m is number of fundamental dimensions. So that is equal to 3 here. So 3 plus 1 variable. So each pi term should contain 4 terms. So number of repeating variables should be equal to number of fundamental dimension, that should be equal to 3, as in this case number of fundamental dimensions is 3. So now we have to choose repeating variable. As I already discussed about methods of selecting repeating variable. So first one, the repeating variable should have, first variable should have geometric property, second one flow property, third one fluid property. We can see here in the problem, t equal to d to the power 5 n square rho of 5 of mu divided by d square n rho. So geometric property, that's a diameter, we can directly take. Now we have confusion with respect to flow property. So we have to search for velocity here. So velocity is not given. So then we can search for angular velocity. Angular velocity omega also not given. Next we can search for n, that is rpm. So rpm it is given in problem. So we can take n as flow property. Then we should go for fluid property, that is we have to search for density first. So here density as well as dynamic viscosity is there, so preference should be given to density. So we can select density as fluid property. So repeating variables d, n and rho as repeating variables, that should be equal to number of fundamental dimensions. In this case it is 3, so I have to select 3 fundamental 3 repeating variables. So we can write now expression for pi 1 and pi 2 like this. Pi 1 equal to d to the power a1 into n to the power b1 into rho to the power c1 into torque. Then pi 2 equal to d to the power a2 n to the power b2 rho to the power c2 into mu, where a1 b1 c1 a2 b2 c2 are exponents. Next, first pi term, that's the expression for pi 1. So substituting dimensions on both sides of pi 1. So pi 1 is given up by pi 1 equal to d to the power a1 into n to the power b1 into rho to the power c1 into torque. So we can substitute dimensions on both sides. So as pi has no dimension, no unit, so m to the power 0, l to the power 0, t to the power 0. That is equal to L to the power a1, dimension for diameter is L, into t to the power minus 1 to the power b1, for dimension for n it is t to the power minus 1, then density to the power c1, so ml to the power minus 3 to the power c1 into ml square t to the power minus 2. This is a dimension for torque. Now as we all know, next step is equating the powers of m, l and t. So first let's equate power of m. So left hand side we have m to the power 0, right hand side we have m to the power c1 and m to the power 1. So by equating power of m, we get 0 equal to c1 plus 1. Therefore c1 equal to, upon rearrangement we can get value of c1 equal to minus 1. Then equating the power of l, left hand side we have l to the power 0, right hand side we have l to the power a1, l to the power minus 3c1, l square and l square. So we can write expression as 0 equal to a1 minus 3c1 plus 2. So this expression by equating power of l. Then we can go for equating the power of t. So t to the power 0 on left hand side, t to the power minus b1 on right hand side, and t to the power minus 2 again on right hand side. So 0 equal to minus b1 minus 2. Therefore b1 equal to minus 2. Now we have values of b1 and c1. Now we can substitute that values in expression 2, that is 0 equal to a1 minus 3c1 plus 2. So in place of c1 it is minus 1, and in place of, okay, b1 I know it is not there, so a1 equal to 3c1 minus 2. So value of a1 is minus 5. So there is a value, a1 value equal to minus 5, b1 equal to minus 2, c1 equal to minus 1. Now we can substitute the values of a1, b1 and c1 in pi 1. That's the first pi term. We get pi 1 equal to d to the power minus 5, as a1 value is minus 5, n to the power minus 2 as b1 value is minus 2, rho to the power minus 1 as c1 value is minus 1 into torque. So just rearrange, positive powers keep in numerator, negative powers you can take to denominator. So that is equal to t divided by d to the power 5 n to the power 2 into rho, as d to the power minus 5 n to the power minus 2 rho to the power minus 1, that goes to denominator and becomes positive. So that is a pi 1 term. Next, second pi term, that is pi 2. So pi 2 equal to d to the power a2 n to the power b2 into rho to the power c2 into mu. So again writing dimensions on both sides of pi 2. So pi 2 has no dimensions, so m to the power 0, l to the power 0, t to the power 0. Then L to the power A2, T to the power minus 1 to the power B2, ML to the power minus 3 to the power C2 into ML to the power minus 1 T to the power minus 1. So that is ML to the power M into L to the power minus 1 T to the power minus 1. That's dimension for mu, dynamic viscosity. Now next step, equating the powers of M, L and T on both sides. So first let's go for equating the power of M. So M to the power 0 on left hand side, and right hand side m to the power c2 and m to the power 1. So 0 equal to c2 plus 1, therefore c2 equal to minus 1. Next, equating the power of L. So left hand side we have L to the power 0, right hand side L to the power a2, L to the power minus 3c2, L to the power minus 1. So we can write expression as this: 0 equal to a2 minus 3c2 minus 1. Therefore a2 equal to minus 2. We can get a2 value later upon getting value of b2. So otherwise you can directly substitute here: 0 equal to a2 minus 3c2 minus 1. 3c2, c2 value is minus 1. Minus 3 into minus 1, that becomes plus plus 3 minus 1. So that is minus plus 2. A2 plus 2, that is equal to 0. So a2 value becomes minus 2. Then equating the power of t. So left hand side we have t to the power 0, right hand side t to the power minus b2, t to the power minus 1. So 0 equal to minus b2 minus 1. So therefore b2 equal to minus 1. So we got values of a2, b2, c2, a2 as minus 2, b2 as minus 1, c2 as minus 1. Then we can substitute the values of a2, b2, c2 in pi 2. We get value of pi 2 as d to the power minus 2 as a2 value is minus 2, n to the power minus 1 as b2 value is minus 1, rho to the power minus 1 as c2 value is minus 1 into mu, or dynamic viscosity. So just rearrange to keep positive powers in numerator, take negative powers to denominator. So mu divided by d square n rho, or mu divided by rho n d square. So there's an expression for pi 2. Now we got values of pi 1 and pi 2. Now we can substitute pi 1 and pi 2 values in equation 2. So that is f1 of t divided by d to the power 5 n square rho, comma mu divided by d to the power 5 n rho, that is equal to 0, or t divided by d to the power 5 n square rho, that is equal to 5 of mu divided by d square n rho. So here you can see here I am writing expression for pi 1. So because a torque expression it is given in problem, so torque so we have to get expression for torque. So you have to just multiply torque equal to d to the power 5 n square rho to other side. So then it becomes t equal to d to the power 5 n square rho function of mu divided by d square n rho. So it is d square n rho, because value of a2 is minus 2. So when it goes to denominator it becomes plus 2. So d square n rho. So expression for torque equal to d to the power 5 n square rho function of mu divided by d square n rho. This is the first problem. Second problem. Next, we can go for next problem. The pressure difference delta P in a pipe of diameter d and length L due to turbulent flow depends on velocity v, viscosity mu, density rho, roughness k. Using Buckingham's Pi theorem, obtain an expression for delta P. This is a very important problem. There are two cases, turbulent flow and viscous flow. This problem is related to turbulent flow. So here the pressure difference delta P, there's a delta P is a pressure difference, P2 minus P1 or P1 minus P2 in a pipe of diameter d. So pipe diameter is capital D, length is L. So due to turbulent flow depends on velocity v, or velocity of flow, that is v, viscosity mu, density rho, roughness k. So using Buckingham Pi theorem, obtain an expression for delta P. Here they specified we have to go for Buckingham's Pi theorem only. Otherwise, if they specify using dimensional analysis, then you can solve the problem using Rayleigh method or Buckingham's theorem. It is left to you. So here they specifically mentioned Buckingham's Pi theorem. So you have to use problem using Buckingham Pi theorem. So solution: given delta P is a function of dlv comma mu comma rho comma k. So we have to get expression for delta p. So that is a delta p is a dependent parameter or variable. Remaining parameters, that is diameter, length, velocity, dynamic viscosity, rho and roughness, those are independent parameters. So we can write expression for dependent parameter as a function of independent. Therefore delta p equal to function of d comma l comma v comma mu comma rho comma k, or we can rewrite the expression as f1 of delta p comma d comma l comma v comma mu comma rho comma k, that is equal to 0. Take it as expression 1. Now we can count here number of variables delta p, d, l, v, mu, rho, k. So total number of variable including dependent and independent, it is 7. So n equal to 7. Next, writing dimensions of each variable. So dimension of pressure. So unit of pressure is Newton per meter square. So Newton can be obtained from F equal to ma kg meter s to the power minus 2 divided by meter square. So it becomes kg meter to the power minus 1 then s to the power minus 2. So dimension for pressure is m l to the power minus 1 t to the power minus 2. Then dimension for diameter, that is L, length also L, then velocity, that is L t to the power minus 1 as distance, velocity is distance by time, then mu, that is dynamic viscosity, unit is Newton second per meter square. So m into L to the power minus 1 t to the power minus 1, then rho m L to the power minus 3, then k, it is very important, roughness it is measured in meter here. So k equal to this, otherwise it is a height of roughness structure, something like that. So k equal to L. So height of peak and all, so that is measured by using micrometer and all. So unit is meter. So k equal to L, as unit of k is meter, so dimension becomes L. Therefore we can write the number of fundamental dimensions m equal to 3, because in we can see in dimensions of various variables we have all values m, l and t. So we can write number of fundamental dimensions m equal to 3. Therefore number of pi terms n minus m from Buckingham Pi theorem, that is 7 minus 3, that is equal to 4. So that means we have to write expression for 4 pi terms, pi 1, pi 2, pi 3 and pi 4. So we can rewrite the expression 2 as like this, f1 of pi 1 comma pi 2 comma pi 3 comma pi 4 equal to 0. We are grouping the variables into 4 pi dimensionless term, that is pi 1, pi 2, pi 3, pi 4. So take it as expression 2. Next, each pi term contains m plus 1 variable. M plus 1 variable. So what is m? Number of fundamental dimension. So here it is 3. So 3 plus 1, that is 4. So each pi term contains 4 terms. So out of 4 terms, 3 should be repeating, because number of repeating variable equal to number of fundamental dimensions. So that is 3 repeating variables. Remaining you have to multiply by one more parameter or variables. So 3 plus 1. Therefore we have to choose now repeating variables. So we have diameter here as geometric property. So we can select diameter as geometric property. Then velocity is given. So velocity we can select as a flow property. Then rho. Rho it is given in problem. Rho and mu. So first preference should be given to density. So rho as repeating variable. So dv rho as repeating variable. Now we can write 4 pi terms as like this. Pi 1 equal to d to the power a1 into v to the power b1 into rho to the power c1 into delta p, that is the pressure difference. Then pi 2 equal to d to the power a2 v to the power b2 into rho to the power c2 into length, that is L is length. Pi 3 equal to d to the power a3 v to the power b3 into rho to the power c3 into mu, where mu is dynamic viscosity. Then pi 4 equal to d to the power a4 d to v to the power b4 rho to the power c4 into k, where k is roughness. So these are expressions for 4 pi terms. Next, let's go for writing expression for getting expression for pi 1. So first pi term, that is pi 1. So substituting dimensions on both sides of pi 1. So pi 1 is d to the power a1 v to the power b1 rho to the power c1 into delta p. Now we have already written dimensions for each of the variables or parameters. So now we can just substitute. Pi 1 it is dimensionless, m to the power 0, L to the power 0 t to the power 0, that is equal to L to the power a1. So for diameter it is L, then V it is L t to the power minus 1, and for rho it is m L to the power minus 3, and delta P it is m L to the power minus 1 t to the power minus 2. So expression becomes m to the power 0 L to the power 0 t to the power 0 equal to L to the power a1 into L t to the power minus 1 to the power b1 into m L to the power minus 3 to the power c1 into m L to the power minus 1 t to the power minus 2. Now next step is equating the powers of m, L and t on both sides. So equating the power of m first. So m to the power 0 on left hand side and m to the power c1, m to the power 1 on right hand side. So 0 equal to c1 plus 1, therefore c1 equal to minus 1. Next, equating the power of L to the power 0 on left hand side and right hand side L to the power a1, L to the power b1, L to the power minus 3c1, L to the power minus 1. So expression becomes 0 equal to a1 plus b1 minus 3c1 minus 1. Therefore a1 equal to 3c1 plus 1 minus b1. So we can write expression for a1 here. Then equating the power of t. So t to the power 0 on left hand side, t to the power minus b1, t to the power minus 2 on right hand side. So 0 equal to minus b1 minus 2. Therefore b1 equal to, we can rearrange and we can get expression for b1 as minus 2. Now we have values of b1 and c1. So we can substitute in second expression for a1 and we can get value of a1 as 3c1, 3 into minus 1, so minus 3, plus 1, minus of minus 2, so plus 2. So a1 value is 0. Now we can substitute values of a1, b1 and c1 in pi 1 and we get pi 1 equal to d to the power 0, v to the power minus 2, rho to the power minus 1 into delta p, that is equal to delta p divided by v square rho. So d to the power 0 it is 1, v to the power minus 2 and rho to the power minus 1, that goes to denominator and becomes positive v square rho. So delta p divided by v square rho. So that is the expression for pi 1 term. Next, second pi term, that is pi 2. So pi 2 equal to d to the power a2, v to the power b2, rho to the power c2 into L. Now we have to substitute dimensions on both sides of pi 2. So we get m to the power 0, L to the power 0, t to the power 0 equal to L to the power a2 into L t to the power minus 1 to the power b2 into m L to the power minus 3 to the power c2 into L. So L is a dimension for small letter L, that is a length. So equating the powers of m, L and t on both sides. First we can go for equating the power of m. So upon equating the power of m, we have m to the power 0 on left hand side, m to the power minus 3c2 on m to the power c2 on right hand side. So 0 equal to c2, therefore c2 equal to 0. Then equating the power of L to the power 0 on left hand side, L to the power a2, L to the power b2, L to the power minus 3c2, L to the power 1 on right hand side. So we can write expression as 0 equal to a2 plus b2 minus 3c2 plus 1. So then equating the power of t to the power 0 on left hand side and t to the power minus b2 on right hand side. So 0 equal to minus b2, therefore b2 equal to 0. Now we got values of b2 and c2, so we can write expression for a2 from equation 2. Therefore a2 equal to minus b2 plus 3c2 minus 1. So b2 and c2 values are 0, 0 plus 0 minus 1, so a2 value is minus 1. Now we can substitute values of a2, b2 and c2 in pi 2. We can get value of pi 2 as pi 2 equal to d to the power minus 1, v to the power 0, rho to the power 0 into L equal to L by d. D to the power minus 1, that goes to denominator and becomes d to the power 1. So expression for pi 2 is L by d. Next, third pi term. So pi 3 equal to d to the power a3, v to the power b3 into rho to the power c3 into mu, where mu is dynamic viscosity. So substituting dimensions on both sides of pi 3, m to the power 0, L to the power 0, t to the power 0 equal to L to the power a3 into L t to the power minus 1 to the power b3 into ml to the power minus 3 to the power c3 into ml to the power minus 1 t to the power minus 1, as dimension for mu is ml to the power minus 1 t to the power minus 1. Then equating the power of m, L and t on both sides. So power of m, so we have m to the power 0 on left hand side and m to the power c3 and m to the power 1 on right hand side. So 0 equal to c3 plus 1, therefore c3 equal to minus 1. Then equating the power of L, so L to the power 0 on left hand side, L to the power a3, L to the power b3, L to the power minus 3c3, L to the power minus 1 on right hand side. So we can write expression as 0 equal to a3 plus b3 minus 3c3 minus 1. Then equating the power of t, so t to the power 0 on left hand side, t to the power minus b3 on right hand side, t to the power minus 1 again on right hand side. So we can get right expression as 0 equal to minus b3 minus b1. Upon rearrangement we can get value of b3 as minus 1. So we can substitute values of b3 and c3 in equation 2 for a3. So a3 equal to 3c3 minus b3 plus 1. So c3 value is minus 1, b3 value is minus 1. 3 into minus 1, that becomes minus 3. Minus 1 into minus 1, that becomes plus 1 plus 1. So that is equal to minus 1. a3 value is minus 1. So we can substitute values of a3, b3, c3 in pi 3 and we can get expression for pi 3 as pi 3 equal to d to the power minus 1, v to the power minus 1, rho to the power minus 1 into mu, that is equal to mu divided by dv rho. So d to the power minus 1, v to the power minus 1, rho to the power minus 1, that goes to denominator and becomes positive. So dv rho, mu divided by rho vd or dv rho. So that is the expression for pi 3. Next, fourth pi term, that is pi 4. So pi 4 equal to d to the power a4, v to the power b4, rho to the power c4 into k, where k is roughness. Then substituting dimensions on both sides of pi 4, we get m0, m to the power 0, L to the power 0, t to the power 0 equal to L to the power a4 into L t to the power minus 1 to the power b4 into m L to the power minus 3 to the power c4 into L. So equating the powers of m, L and t on both sides. Power of m, so let's go for equating the power of m first. So m to the power 0 on left hand side, m to the power c4 on right hand side. So 0 equal to c4, therefore c4 equal to 0. Then equating the power of L, L to the power 0 on right hand side, left hand side, L to the power a4, L to the power b4, L to the power minus 3 c4 and L on right hand side. So 0 equal to a4 plus b4 minus 3c4 plus 1. So then equating the power of t, t to the power 0 on left hand side, t to the power minus b4 on right hand side. Therefore b4 equal to 0. Then we can substitute b4 and c4 value in equation for a4. Therefore a4 equal to 3c4 minus b4 minus 1. As the values of c4 and b4 are 0, so we can get value of a4 as 0 minus 0 minus 0 minus 0 minus 1, that is equal to minus 1. Now substitute values of a4, b4 and c4 in pi 4. We get value of pi 4 as pi 4 equal to d to the power minus 1, v to the power 0, rho to the power 0 into k. Upon rearrangement we can get value of pi 4 as k by d, that is fourth pi term. Next, substituting the values of pi 1, pi 2, pi 3 and pi 4 in equation second, that is f1 of pi 1, pi 2, pi 3, pi 4 equal to 0. So just substitute values of pi 1, pi 2, pi 3 and pi 4. So f1 of delta p divided by v square rho, L by d, mu divided by dv rho, k by d equal to 0. But we want expression for delta p here. So delta p equal to delta p divided by v square rho, or expressing pi 1 as a function of remaining pi terms. So delta p divided by v square rho is equal to pi of L by d, mu by dv rho, k by d. So we can just cross multiply v square rho to the right hand side. Delta p equal to v square rho function of L by d, mu by dv rho, k by d. So this is an expression for pressure drop. So if they ask in problem, get expression for HF, there's a friction head or difference of pressure head, then step is you have to continue step from here. Still delta p you have to continue, you have to get expression for delta p, then you can get expression for HF if they ask only, otherwise this is not necessary. From experiment, it was observed that pressure difference delta p is linear function of L by d. and hence it is taken out of function. So L by D, so L by it is from experiment it is proved that L by D is delta P is a linear function of delta L by D. So we can just take L by D out. So delta P equal to V square rho into L by D function of mu divided by dV rho comma K by D. So we can take L by D from the function. Then HF equal to, but expression for HF you have to remember, that is delta P divided by rho G. Now we have delta P value, so you just divide delta P divided by rho G. So V square rho into L by D divided by rho G into function of mu divided by dV rho comma K divided by D. So that is equal to V square divided by G, because rho terms you can cancel, V square divided by G into L by D function of mu divided by dV rho comma K by D. So now function of mu divided by dV rho comma K by D contains two terms, as we can see there, mu divided by dV rho as first term, K by D as second term. But first one, mu divided by dV rho or rho by D, which is 1 by Reynolds number or 1 by Re. So as I already discussed about that thing in model analysis or dimensionless terms, so Reynolds number, so that is given by rho by D by mu. So here it is mu divided by rho by D, so it becomes 1 by Re, or Re equal to rho by D by mu, because of Re Reynolds number equal to rho by D by mu. So here it is mu divided by dV rho, so it is inverse, so or reciprocal, 1 by Reynolds number or 1 by Re. And second one, second term is K by D, which is called roughness factor, because K is related to roughness, so it is called as K by D is called as roughness factor. Now function of 1 divided by Re comma K by D is put equal to F. They are going to take function of 1 by Re comma K by D is equal to F, where F is called as coefficient of friction. They are giving name for F as coefficient of friction, which is a function of Reynolds number and roughness factor, because 1 by it is first term is related to Reynolds number, second term is related to roughness. So friction factor, you are altogether taking two terms as friction factor. So friction factor is a function of Reynolds number and roughness factor. So HF equal to delta P by rho G, that is equal to, in place of phi of 1 by Re comma K by D, we are taking it as 4F by 2. So 4F by 2 into V square L divided by GD, since F equal to function of 1 by Re comma K by D. So here F is taken as phi of 1 by Re comma K by D, and you know for dimensionless terms you can multiply and divide by any constant, that is not going to alter the value. So delta P equal to rho G, that is actually V square L divided by GD into F. So they are multiplying here 4 divided by 2, 4 then it becomes 4F by 2 into V square L divided by GD. So multiplying and divided by any constant does not change the character of pi terms. That's what I told. So you can multiply by 4 and you can divide by 2. So it is not going to change the value. So HF equal to delta P divided by rho G, that is equal to, you can simplify or you can rewrite the expression as 4F LV square or 4F V square L divided by 2GD. So that is the expression for HF or pressure head or friction head. So you have to just remember friction head is given by delta P divided by rho G. So you have to divide entire term by rho G. Then you have to assume from experiments it is observed that delta P is a linear function of L by D. So you can take out. Then remaining term you have to take it as F. Then you have to multiply and divide by 4 and you have to multiply by 4 and divide by 2. Then get expression for HF. So this is not necessary if they are not going to ask get expression for HF. If they ask the pressure difference, then you have to just get expression for delta P. That's it. Next, last problem. The pressure difference delta P in a pipe of diameter D and length L due to viscous flow depends on velocity V, viscosity mu, density rho and roughness K. Using Buckingham's Pi theorem, obtain an expression for delta P. So you can see here, this question was asked so many times in exam, December 2018, December 2017, December 2015 and all. So this is very important problem. Two problems. One is due to turbulent flow, other one is viscous flow. So viscosity is, you know, viscous flow means viscosity means resistance flow. There are two types of viscosity, dynamic and kinematic viscosity. So here the dynamic viscosity is very important because the flow is due to viscosity. So this problem is similar to previous problem. The only difference is that delta P is to be calculated for viscous flow, because we calculated previous problem for turbulent flow. So here we have to calculate for viscous flow. Then the repeating variable instead of rho, the fluid property mu is to be chosen. So here you have to see here actual rho as well as mu terms both are there, but in the problem it is given it is due to viscous flow. So importance should be given for viscosity. So in place of rho you have to take it as mu as repeating variable corresponds to fluid property. So given delta P is a function of d, L, V, mu, rho, k as similar to previous problem. So here, roughness is k, then delta P equal to f of d, L, V, mu, rho, k. So we can write expression for delta P. There is a dependent parameter to get expression for delta P. So delta P is dependent. So I have to express delta P as a function of independent parameters. Or we can write f1 of delta P, d, L, V, mu, rho, k, that is equal to 0. So rewrite the expression delta P as like this. Then we can count here delta P, d, L, V, rho, mu, rho, k. So total number of variables equal to 7. So n equal to 7. Next, writing the dimension of each variable. For delta P, as I already explained, unit is Newton per meter square. So dimension becomes m into L to the power minus 1, t to the power minus 2. For diameter it is L, length it is L, v for velocity L, t to the power minus 1, mu it is m L to the power minus 1, t to the power minus 1, rho it is m L to the power minus 3. Therefore number of fundamental dimensions m equal to 3. So number of pi terms n minus m, that is equal to 6 minus 3, that is equal to 3. So here you have to see here roughness is not given. So in some of the cases they are going to give you roughness, then you are going to get number of dimensions equal to n equal to 7. So here roughness value is not necessary, it is not given. So you can just neglect number of variables equal to 6, 6 minus 3 equal to 3. So now equation can be grouped into 3 pi terms as f1 of pi 1, pi 2, pi 3 equal to 0. Because from Buckingham Pi theorem, dimensionless terms, number of dimensionless terms equal to n minus m. So n minus m means 6 minus 3. So that is equal to 3. So 3 pi terms you are going to get. Each of pi term contains m plus 1 or 3 plus 1 variable. So out of 4 variables, 3 are repeating variable. So 4 variables we have, 3 plus 1, 3 is like number of fundamental dimension. So repeating variable should be equal to number of fundamental dimensions. Choosing dv mu as repeating variable. So as I already told, in place of rho, you have to see whether the flow is due to viscosity or turbulent flow. So here it is viscosity, so mu should be given importance. So dv rho, instead of rho you have to select mu as fluid property. So repeating variable, we have 3 pi terms. Pi 1 equal to d to the power a1, v to the power b1, mu to the power c1 into delta p. Then pi 2 equal to d to the power a2, v to the power b2 into mu to the power c2 into L. Pi 3 equal to d to the power a3, v to the power b3 into mu to the power c3 into rho. So writing expressions for 3 pi terms. Then first pi term, substituting dimension on both sides of pi 1, m to the power 0, L to the power 0, t to the power 0 equal to L to the power a1 into L t to the power minus 1 to the power b1 into m L to the power minus 1 t to the power minus 1 to the power c1 into m L to the power minus 1 t to the power minus 2. Then equating the powers of m, L and t on both sides. So first let's go for equating the power of m. So 0 equal to c1 plus 1, as on left hand side m to the power 0, right hand side m to the power c1, m to the power 1. So 0 equal to c1 plus 1, therefore c1 equal to minus 1. Then equating the power of L. So 0, L to the power 0 on left hand side, L to the power a1, L to the power b1, L to the power minus c1, L to the power minus 1 on right hand side. So expression 0 equal to a1 plus b1 minus c1 minus c1. Therefore a1 equal to c1 plus 1 minus b1. So we can write expression like this. A1 equal to c1 plus 1 minus b1, just rearranging. Then equating the power of t. So t to the power 0, t to the power minus b1, t to the power minus c1 and t to the power minus 2. So we get expression for t as equating the power of t as 0 equal to minus b1 minus c1 minus 2. Therefore b1 equal to minus c1 minus 2. So c1 value is minus 1. So minus of minus, that becomes positive. So 1 minus 2, that is minus 1. Now we have values of b1 and c1. So we can substitute in a1. So get a value of a1. So a1 equal to minus 1 plus 1 plus 1 equal to 1. Just get substitute values of c1 and b1. Then substituting the values of a1, b1 and c1 in pi1, we get expression for pi1 as this. Pi1 equal to d to the power 1, v to the power minus 1, mu to the power minus 1 into delta p, that is equal to delta p into d divided by mu v. So that is the expression for pi1. Then second pi term, that is pi2. So pi2 equal to d to the power a2, v to the power b2 into mu to the power c2 into el. Substituting the dimensions of both sides of pi2. So I have to substitute dimensions on both sides of pi2. So m to the power 0, l to the power 0, t to the power 0, that is equal to l to the power a2, l t to the power minus 1 to the power b2 into m l to the power minus 1, t to the power minus 1 to the power c2 into l. So equating the powers of m, l and t on both sides. So power of m, by equating the power of m to the power 0 on left hand side, m to the power c2 on right hand side. So 0 equal to c2, c2 equal to 0. Then equating the power of l to the power 0 on left hand side, l to the power a2, l to the power b2, l to the power minus c2, l to the power 1 on right hand side. So 0 equal to a2 plus b2 minus c2 plus 1. Then equating the power of t to the power 0 on left hand side, t to the power minus b2 on right hand side, t to the power minus c2 on again on right hand side. So 0 equal to minus b2 minus c2. c2 value we already obtained as 0. So 0 equal to minus b2 minus 0. So b2 equal to minus c2. That is also equal to 0. Now we have values of c2 and b2 as 0. So we can substitute in value of for a2. a2 equal to minus b2 plus c2 minus 1. So 0 plus 0 minus 1. So that is equal to minus 1. Now we can substitute values of a2, b2 and c2 in pi2. We can get value of pi2 as pi2 equal to d to the power minus 1, v to the power 0, mu to the power 0 into l equal to l by d. So just taking d to the power minus 1 to the denominator, then it becomes positive. So that is equal to l by d. Next, third pi term, that is pi3. So pi3 equal to d to the power a3, v to the power b3 into mu to the power c3 into rho. So substituting the dimensions on both sides of pi3, m to the power 0, l to the power 0, t to the power 0 equal to l to the power a3 into l t to the power minus 1 to the power b3 into m l to the power minus 1 t to the power minus 1 to the power c3 into m l to the power minus 3. Then equating the powers of m, l and t on both sides. First let's go for equating the power of m. So m to the power 0 on left hand side, 0 equal to right hand side it is m to the power c3 and m to the power 1. So 0 equal to c3 plus 1, therefore c3 equal to minus 1. Then equating the power of l, 0 equal to a3 plus b3 minus c3 minus 3, as left hand side we have l to the power 0, right hand side l to the power a3, l to the power b3, l to the power minus c3 and l to the power minus 3. So from that we can get expression for a3 as a3 equal to c3 minus b3 plus c plus 3. So that is equal to, I can calculate later. Then equating the power of t. So t to the power 0 on left hand side, t to the power minus b3, t to the power minus c3 on right hand side. So 0 equal to minus b3 minus c3, therefore b3 equal to minus c3. So c3 value we have minus 1. So minus into minus, that becomes positive. So b3 value is plus 1. Now we have values of b3 and c3. So we can substitute in expression for a3. So a3 equal to c3 minus b3 plus 1. So minus 1 plus 3, that is equal to 1. Now substitute values of a3, b3 and c3 in pi3. We get value of pi3 as pi3 equal to d to the power 1, v to the power 1 into mu to the power minus 1 into rho. So we can get expression for pi3 as rho vd by mu or dv rho divided by mu. So that is a third pi term. Next, substituting the values of pi1, pi2 and pi3 in equation 2, that is f1 of pi1 comma pi2 comma pi3. So that is equal to 0. So we can just substitute f1 of d delta p divided by mu v comma L by d comma dv rho by mu, that is equal to 0. Now we want expression for delta p. So just express pi 1 as a function of remaining two pi terms, that is pi 2 and pi 3. So d into delta p divided by mu v, that is a pi 1, equal to function of our phi of L by d comma dv rho by mu. So delta p equal to just cross multiply mu v divided by rho to the other side. So delta p equal to mu v divided by d function of L by d comma dv rho comma mu. But experiments show that the pressure difference delta p is a linear function of L by d. So as I already told that L by d in a previous problem also, pressure difference is a linear function of L by d. So when it is a linear function, then you can just take out from the function, that is a phi. So L by d can be taken out of function. So delta p equal to mu v d into L by d function of dv rho by mu. So this is the expression for delta p. So you can just write expression for delta p. From this you can get expression for friction head as well. That is hf equal to delta p divided by rho g. So you have to just rearrange mu v divided by d into L by d. So that becomes mu v into L divided by d square into function of dv rho divided by mu. So just divide this expression by rho g. Then you can take it as a function of Reynolds number. So that's it. So you can get expression for hf. Here they didn't ask about friction head or pressure head. So you can stop in expression for pressure delta p. These are pressure difference. So this is a solution. Two important problems I discussed here. Three. So first one is expression for torque, that is also very important. Then turbulent flow and viscous flow. Viscosity you have to remember instead of rho, as rho value is given in the problem. Don't get confused. Don't take rho as repeating variable. So viscosity means it is due to viscous force. So you have to take mu as repeating variable in place of rho. Whereas in turbulent flow, even though a mu value is given, you have to take rho as repeating variable. So that's the conclusion from these three problems. Okay, I'll come up with more problems in next video. Thank you.